Understanding the waterfall model in software development. The waterfall model is a traditional, sequential software development methodology. It's structured, linear, and leaves little room for backtracking. Route 1. Requirements gathering. The project team collects all requirements from the client or stakeholders. The aim is to define the project's scope and objectives clearly. 2. System design. Here, the system architecture and design are developed based on the gathered requirements. This includes creating high-level and low-level design documents. 3. Implementation. After the system design is complete, the actual coding and programming work begins. Developers write the code based on the design specifications. 4. Testing. Once coding is done, testing takes place. The software is thoroughly tested to ensure it meets the specified requirements and functions as intended. 5. Deployment. After testing, the software is deployed or installed in the client's environment. 6. Maintenance and support. Post-deployment, the system may require ongoing maintenance and support to address issues, fix bugs, and make necessary updates or enhancements. The waterfall model has well-defined goals, and progress moves in a linear, sequential fashion. It's best suited for projects with stable requirements, where changes are expected to be minimal. However, it's less adaptable to changing requirements or evolving project needs. If requirements change significantly after the project has progressed, it can be challenging and costly to make adjustments. As a result, more modern software development methodologies like Agile have become popular to address the need for flexibility and iterative development. But the waterfall model still holds its place for projects with well-defined and stable requirements. Waterfall model versus spiral model. Which is better? What's better, the waterfall model or spiral model? It depends on your project's type and scope. Waterfall is best for projects with stable requirements. Phases are completed sequentially, with minimal room for changes. Risk is low early on, but increases as the project progresses. It's ideal for smaller projects with clear objectives. Spiral suits complex projects with evolving requirements. It allows iterative development with multiple cycles of planning, design, implementation, and evaluation. It emphasizes risk management and provides flexibility for changes. It's perfect for large, long-term projects where adaptability is key. In summary, waterfall is great for well-defined projects, while spiral is better for complex, evolving ones. Evaluate your project's needs, flexibility required, and your organization's culture when choosing a model. Some even use a hybrid approach for unique circumstances. The V model, a systematic approach to software development. Meet the V model, a sequential software development approach. It's like the waterfall model, but with a twist. Each development phase corresponds to a testing phase, ensuring a disciplined, interconnected cycle. The secret? Each phase starts only after the previous one is successfully completed. A methodical way to ensure quality. Understanding Agile methodology. Agile is a methodology that promotes continuous iteration of development and testing throughout a project's lifecycle. Developers and testers work together, fixing errors mid-project. Customers get early and frequent opportunities to review the product and make changes. Small projects can be implemented quickly. For larger ones, estimating development time is challenging. The development process is iterative, executed in short 2 to 4 week iterations with minimal planning. At every sprint's end, user acceptance is performed. Understanding Scrum, a framework for agile software development. Scrum is a framework in agile methodology, a solution for executing complex software application tasks. It helps focus on all aspects of a product like quality, performance, and usability. There are 3 key roles in Scrum. The Scrum Master sets up the team and removes obstacles. The product owner defines product features, decides release dates, and prioritizes tasks. The development team organizes and schedules their work independently. Scrum process includes user stories, product backlog, release backlog, sprints, and sprint backlog. User stories divide work into tasks. The product backlog is a collection of user stories prioritized by the product owner. The release backlog is where the team prioritizes user stories. Sprints are set periods of time to complete user stories. The sprint backlog is the list of tasks to be performed in a sprint. Scrum ceremonies include sprint planning, daily scrum, and sprint review. Sprint planning begins with importing stories from the release backlog into the sprint backlog. Daily scrum is a 15-minute meeting where the team discusses work completed and planned. Sprint review is a retrospective, where the team discusses accomplishments and lessons learned. Scrum is a powerful tool for managing complex software development projects, focusing on quality, performance, and usability. It's all about teamwork, prioritization, and continuous improvement. Introduction to Maven. Maven is a build automation tool, primarily for Java projects. It's a must-have for JDK users. Maven enhances reusability and manages dependencies, storing all project jars and downloading dependency jars from central repositories. At the heart of Maven is the POM XML file. This is where we keep all the required information, including all the dependencies. It's the core of any Maven project. Introduction to Page Object Model. Page Object Model is a framework that enhances test maintenance and reduces code duplication. It makes code more readable, maintainable, and reusable. Imagine 10 scripts using the same page element. A change in that element means updating all 10 scripts. With Page Object Model, create a class file for web elements. This file can be reused in all scripts, making changes easier and less error-prone. What is framework in automation testing? A testing framework in automation is like a rulebook for writing and organizing test cases efficiently. It provides guidelines for easy use and modification. Tools like Eclipse and IntelliJ aid in coding for Selenium WebDriver. Different frameworks like data-driven, keyword-driven, and hybrid offer organized approaches to writing tests. Tools like Jenkins, Jira, and GitHub complement the process for continuous integration, project management, and version control. BDD is a framework where we write the test cases before development starts. The product owner gives requirements. Then, developers, testers, and business analysts participate in a meeting. Based on the acceptance criteria, we start writing feature files using Cucumber Gherkin language in a given, when, then format. Cucumber is a testing tool supporting behavior-driven development. It lets us define application behavior in plain English using a language called Gherkin. Cucumber feature files can serve as a good document for all. TDD is a development approach where we write tests before writing the actual code. The process involves creating a test, writing the minimum code to pass it, running tests, and then refactoring. It ensures code quality, clarity, and bug-free development. TDD focuses on testing individual code units with technical language. BDD emphasizes collaboration, testing system behavior using a more natural, given-when-then language. Data-driven testing is a creation of test scripts where the test data values are read from data files. It is performed when the values are changing by the time. The different data files may include data pools, CSV files, and Excel files. JUnit is a testing framework for unit testing. It uses Java as a programming platform and is open-source software managed by the junit.org community. It is important in the test-driven development process. In JUnit, we keep all test cases related to functions in one method. TestNG, Testing the Next Generation, is a Java unit testing framework that aims to overcome many limitations of JUnit. TestNG introduces new functionalities that make it more powerful and easier to use, such as flexible test configuration, support for data-driven testing, and support for parameters. TestNG is designed to cover all categories of tests: unit, functional, integration, end-to-end, etc. What is Jira? Jira is a versatile tool used for bug tracking, issue tracking, and project management. It's a platform-independent tool that helps track issues and bugs related to your software and mobile apps. Jira is widely used by software project development teams, help desk systems, and leave request systems. In quality assurance teams, it's used for bug tracking project-level issues like documentation completion, and for tracking environmental issues. Jira operates on 3 core concepts. First, every task, bug, enhancement request, and anything to be created and tracked via Jira is considered an issue. Second, a collection of issues. And third, a workflow, which is the series of steps an issue goes through from creation to completion. Creating an issue in Jira involves several steps. First, choose the default Sakai. Then, select the issue type, usually the default bug. Provide a brief but insightful summary of the issue and enter the appropriate priority. Next, select all related components or tools. Indicate the version where the issue was observed, and choose the default unknown for the fix version, unless you know the version where the issue is expected to be fixed. The assignee should be unassigned for fastest review or the default automatic to automatically assign the issue to the project owner. You are the reporter. Provide relevant details about the environment where the issue occurs, a complete description of the issue, and attach any relevant files. Leave the original estimate blank. If the issue involves security exploits, set the security level to security issue. Leave the security field unchecked. Finally, describe the steps and setup needed to recreate the issue in the test plan. This will be used to test the issue once it has been fixed. The maintenance branch status field indicates whether the fixed issue should be merged into that branch. Choose the default none, unless you know this should be merged into this branch. In conclusion, Jira is a powerful tool that helps teams track and manage issues effectively, ensuring smooth project execution. 1. What is Jenkins? Jenkins is a continuous integration software tool written in the Java programming language for testing and reporting on isolated changes in a larger codebase in real time. It monitors the execution of the steps and allows stopping the process if one of the steps fails. It allows the users notifying the build success or failure. Jenkins can be started via the command line or can run in a web application server. Under Linux, you can also install Jenkins as a system service. Understanding version control systems are Ever wondered how software developers and testers collaborate efficiently? They use a tool called a version control system. It's software that maintains a comprehensive history of their work. This system allows developers and testers to work simultaneously without overwriting each other's changes. It keeps a complete history of every version, making collaboration smooth and efficient. There are 2 main types: Centralized Version Control System, CVCS, and Distributed Version Control System, DVCS. CVCS uses a central server to store all files, promoting team collaboration. But it has a drawback. If the central server goes down, collaboration halts. In a worst-case scenario, a corrupted server disk without a backup could mean losing the entire project history. On the other hand, DVCS, like Git, allows clients to fully mirror the repository. If the server goes down, any client's repository can restore it. Each checkout serves as a full backup. The strength of Git lies in its independence from the central server. You can commit changes, create branches, and view logs offline. A network connection is only needed to publish and fetch the latest changes. So, that's a quick look at version control systems, the unsung heroes of software development and testing. What is GitHub and Git? Let's dive into the world of GitHub and Git. They're essential tools for programmers. But what exactly are they? GitHub is a web-based hosting service for software development. Think of it as Facebook for programmers. It's a place where everyone can share their code, make suggestions, or changes. It's a hub for collaboration, making it easy to offer suggested changes to others' code. Now, let's talk about Git. Git is a distributed version control system and source code management system. It's designed to handle projects of all sizes with speed and efficiency. In Git, a repository contains a directory named .git, where Git keeps all of its metadata for the repository. It's like the brain of your project. Comparing Git to SVN, another version control system, there are some differences. Git is less preferred for handling extremely large or frequently changing binary files. SVN, on the other hand, can handle multiple projects stored in the same repository. There are many advantages to using Git. It offers data redundancy and replication, high availability, and it's collaboration-friendly. Plus, any sort of project can use Git. There are several key functions in Git. Git clone is used to create a copy of an existing Git repository. Git config is used to set configuration options for your Git installation. And with the git init command, you can create a new repository. In Git, a head is a reference to a commit object. In every repository, there's a default head referred to as master. But a repository can contain any number of heads. A conflict in Git arises when the commit that has to be merged has some change in one place, and the current commit also has a change at the same place. To resolve this, you edit the files to fix the conflicting changes, then add the resolved files by running git add, and finally commit the repaired merge with git commit. There are many other useful Git commands. Git status shows the difference between the working directory and the index. Git rm removes the file from the staging area and also off your disk. Git add adds file changes in your existing directory to your index. Git fetch fetches all the objects from the remote repository that are not present in the local one. Git pull fetches the files from the remote repository and merges it with your local one. Git push pushes all the modified local objects to the remote repository and advances its branches. In conclusion, GitHub and Git are powerful tools for programmers. They facilitate collaboration, version control, and efficient project management. So, if you're a programmer, it's time to get familiar with GitHub and Git. Understanding SDLC and STLC in software engineering. In software engineering, two crucial processes are the software development lifecycle, SDLC, and the software testing lifecycle, STLC. Each plays a unique role in the journey of software development and testing. SDLC covers the whole process of software development. It starts from the initial concept and goes all the way to the deployment of the final product. This includes phases like requirements gathering, design, coding, testing, deployment, and maintenance. STLC, on the other hand, is a part of SDLC. It focuses specifically on the testing aspects of software development. STLC involves planning, designing, executing, and managing tests to ensure the software's quality and functionality. In a nutshell, SDLC provides a comprehensive roadmap for the entire software development process. Meanwhile, STLC guides the testing phases within that broader development framework. Both are vital components of a well-structured software engineering process. Understanding testing methodologies. Testing methodologies are vital for ensuring software quality. Let's explore the three main methods. 1. Black box testing. This focuses on the application's functionality, not its internal structure. Test engineers, who may not know the application's code in depth, identify inputs, determine expected outputs, execute test cases, and compare actual results with expected results. 2. White box testing. This zeroes in on the application's internal structure, logic, and code. Developers are dedicated white box testers who understand the application's internals, design test cases based on code structure, execute these, and validate that the code functions as expected. 3. Gray box testing. This combines elements of both black box and white box testing, examining functionality and internal structure. Test engineers with some knowledge of the application's internal structure gather information about functional requirements and internal code, design test cases covering both aspects, execute these, and verify that the application functions correctly from both a user and code perspective. Each methodology serves a specific purpose, contributing to a comprehensive testing strategy based on the project's needs and requirements. Understanding these methodologies can help ensure the quality of your software. Levels of software testing. There are 5 key levels of software testing. Each level has a unique purpose and is crucial for ensuring a high-quality software product. First, we have unit-level testing. This is a white box testing method, typically performed by developers or white box testers. It focuses on individual units of the software. Second is module-level testing. A module is a group of related functionalities performing a major task. This level involves black box testing, usually carried out by test engineers. Third, we have integration-level testing. Here, developers create interfaces to integrate the modules. They then test if these interfaces are working correctly. This is another white box testing method. Fourth is system-level testing. The complete application is installed into the environment for testing. This level includes various types of testing, one of which is system integration testing. System integration involves testing the complete application. An action is performed at one module, and the reflections at the corresponding modules are checked. This is a black box testing method, usually performed by test engineers. Finally, we have user acceptance testing, or UAT. This involves performing system testing in the presence of the user to gain their acceptance of the application. This is a black box testing method, usually performed by test engineers. UAT has 2 types. Alpha testing, where test engineers test the application in the company's presence. And beta testing, where testing is done at the client's place by end users or third-party testing experts before actual implementation. Remember, each level of testing is crucial for ensuring a high-quality software product.
Types of software testing. Software testing is a crucial part of software development. Let's explore the different types of software testing. 1. Build acceptance testing, also known as build verification testing or sanity testing, is an overall testing of the released build to check if it's suitable for further detailed testing. 2. Regression testing involves testing already tested functionalities repeatedly. This is done when defects are rectified or new features are added. 3. Retesting is testing the same functionality with different sets of values to determine if it's working. 4. Alpha testing is a type of user acceptance testing, where test engineers test the application in the company's presence. 5. Beta testing is user acceptance testing done at the client's place by end users or third-party testing experts before actual implementation. 6. Static testing involves testing the application or related factors without performing any action, like documentary testing or code reviews. 7. Dynamic testing involves testing the application by performing some actions, like functionality testing. 8. Compatibility testing involves deploying the application in multiple environments to check if the application is compatible with all environments. 9. Monkey testing involves performing abnormal actions on the application to check its stability. 10. Usability testing checks if the application is user-friendly and comfortable for the end user. 11. Exploratory testing is performed by domain experts who test the application by exploring its functionality without knowledge of requirements. 12. End-to-end testing involves testing all the end-to-end scenarios of the application. 13. Port testing involves deploying the application in the client's environment to check its compatibility. 14. Reliability testing involves testing the application continuously for a long period to check its stability. 15. Security testing checks how secure the application is. This includes authentication testing, direct URL testing, and firewall leakage testing. 16. Mutation testing involves testing something by making changes to it. 17. Ad hoc testing involves testing the application in one's own style after understanding the requirements clearly. Understanding these types of software testing can help ensure a high-quality, reliable, and secure software product.